You tech tick. All right, let's jump into it. This mod is Three Aperture Rules, and it's about aperture dimensions for optimal stencil printing. Here's a look at the outline for this module. We'll start out by identifying different aperture dimensions that are present on a stencil. Then we'll take a look at the two dimensions used in the aspect ratio rule. Next, we'll get to know the area ratio rule, which uses all the dimensions of an aperture as well as the area of the pad beneath it. After that, we'll consider the size of metal balls and solder paste in order to establish the 5-ball rule. Finally, we'll go through a summary of these three rules that are used for guiding us towards better stencil printing. We're doing this for a reason, because when we're done, you want to be able to do certain things. When you're done with sections 1 and 2, you should be able to name the three dimensions of a rectangular stencil aperture. Given those three dimensions, you should be able to identify the two dimensions used in the aspect ratio. After that, you should be ready to calculate the aspect ratio for a rectangular stencil aperture. When you complete section 3, you should be able to describe the area ratio rule in words. For example, a good description might be this divided by that. Then you'll want to calculate the area ratio for a rectangular stencil aperture and apply the rule. After completing section 4, you should be able to state the 5-ball rule in words. And once you have the maximum ball sizes for types 3, 4, and 5 solder paste, you should be able to tabulate the minimum aperture widths for each of these solder types using the 5-ball rule. And finally, after the summary section, you should be able to name the 3 aperture rules. This first section is about aperture dimensions and what that means for the area of the printed pad. Printed circuit boards have many copper pads on their surface, and stencils have many apertures in the stainless steel foil. In this module, we'll focus on one pad and one aperture at a time. Here we have a single copper PCB pad in orange on the left, and the walls of a single stainless steel stencil aperture in silver on the right. And the stencil aperture goes on top of the copper PCB pad. There are 3 major steps involved in delivering solder paste onto a PCB using a stencil. A stencil is used to place an aperture on the pad of a board. Then the aperture is filled with solder, usually with a squeegee. Finally, the pad and aperture are distanced from each other, leaving the solder paste behind on the pad. A rectangular stencil aperture has 3 dimensions of interest to us. The length is considered here to be the greatest of the 2 planar dimensions of the aperture. Width is the lesser of the 2 planar dimensions of the aperture. And thickness is the 3rd dimension of the stencil aperture walls, which we'll take to be identical to the overall stencil thickness. The surface of the pad has similar length and width, though they can vary somewhat from the aperture dimensions. Okay, so here's the question for you. What are the names of the 3 aperture dimensions? If you can answer that, you're ready to move on to the next section. This next section introduces our first rule, the aspect ratio rule. First, we need to define the aspect ratio, which we can do 2 different ways. It can be stated in words. The aspect ratio is the smallest 2D dimension, which for us is always the width, divided by the stencil thickness. Or we could use an equation. The aspect ratio is equal to W divided by T. Now that we know what the aspect ratio is, we want to take a look at the rule that uses the aspect ratio. In words, The rule is that the aspect ratio should be more than 1.5. As an equation, we would write W divided by T is greater than 1.5. Why should we use the aspect ratio rule? Well, because it's been found that if the aspect ratio is less than 1.5, when the stencil and the pad are separated, it is more likely that there will be solder paste left behind in the aperture, and therefore not delivered to the pad. So, what do you do if an aperture breaks the rule? That is to say, if W divided by T is less than 1.5, then what changes can be made to bring it above 1.5? You can increase the aperture width, which would increase the value of the aspect ratio, or you might decrease the stencil thickness, which would also increase the ratio. Remember, whether you increase W or decrease T, you need to do it enough to bring up the aspect ratio to greater than 1.5. Now it's time to check out the objectives for this section. The first objective is to identify the two aperture dimensions used in the aspect ratio. Next, we'll go through an example of calculating the aspect ratio. Then, you'll be asked to do it on your own. So here's the example in detail. An 0402 resistor has pad dimensions length equal to 0.5 millimeters and width equal to 0.4 millimeters. Assuming the stencil aperture has the same length and width as the pad, and the thickness of the stencil is 5 mils, which means T is equal to 0.005 inches. Because the thickness is in inches and the width is in millimeters, we need to convert units so that W and T are the same. The 5 millimeter stencil has a thickness of 0.005 inches. If we multiply that by the ratio of 25.4 millimeters per 1 inch, then the inches cancel out and we get 0.127 millimeters for the stencil thickness. That gives an aspect ratio of 0.4 millimeters divided by 0.127 millimeters, giving 3.15 as the ratio. And 3.15 is greater than 1.5. So therefore, this example passes the aspect ratio rule. Now it's your turn to calculate the aspect ratio. An 0201 resistor has pad and aperture dimensions of length equal to 0.3 millimeters and width equal to 0.27 millimeters. In addition, the stencil thickness is 6 mils. So to meet the final objective for this section, you need to be able to calculate the aspect ratio for this aperture and apply the aspect ratio rule. You can do this. I know you can. And when you're done, I'll see you in the next section. Okay, welcome to the next section, which is about the area ratio and the rule that goes with it. This rule is more detailed than the aspect ratio rule and gets us closer to the nitty-gritty of what's really going on in those apertures. So let's define the area ratio. In words, the area ratio is the printed area of the pad divided by the total area of the aperture walls. In the figures below, you can see the stencil aperture walls and the pad that goes with it. The aperture dimensions of length, width, and thickness will determine the total area of aperture walls. And the printed area of the pad is determined by the same length and width of the aperture, since the only printed part of the pad is that exposed to the stencil aperture. Now we're going to be calculating the area of a printed pad. The area of the printed pad, APP, is equal to the two-dimensional area of the stencil. More specifically, APP is equal to the length of the aperture times the width of the aperture. The aperture determining the amount of pad that is printed. Next, we need to calculate the area of the stencil aperture walls. We'll call that AAW, and it's equal to the sum of 4 separate rectangles. This can be seen by cutting the corners of the aperture to reveal the inner surface of each of the 4 rectangular sides. So let's take a look at each of the 4 rectangular sides. The area of the first rectangle is equal to the width times the thickness of the aperture, and so is the area of rectangle 3. Now the area of rectangles 2 and 4 are equal to the length times the thickness of the aperture. The area of the aperture walls is equal to the sum of all 4 of these rectangles. That gives us 2 times WT and 2 times LT. Pulling the 2T outside gives the area of the aperture walls as 2T times W plus L. Time to meet the first objective. Describe the area ratio rule in words. This divided by that. How do we use the area ratio rule? The area ratio is equal to the area of the printed pad divided by the area of the aperture walls, which in turn is equal to WL divided by 2 times the stencil thickness, T, times W plus L. The area ratio rule states that the area ratio should be greater than 0.66. Okay, now that we know the ratio and the rule, how do we use it? If the area ratio is less than 2/3, then you should seriously consider decreasing the stencil thickness. Time to meet another objective. Describe the area ratio rule in equation form. So let's give it a try. Here's an example. Given the aperture dimensions of T equal to 6 mil, L equal to 0.5 millimeters, and W equal to 0.4 millimeters, and a printed pad area equal to L times W, we want to calculate the area ratio and then apply the area ratio rule. First, we need to convert the thickness T from mils to millimeters so that the units used in the area ratio are all the same. This is very important. Next, we calculate the area ratio by dividing the area of the printed pad by the area of the aperture wall. This equal to W times L divided by 2T times W plus L, and gives the following numbers based on the diagram above and the converted thickness. 0.4 times 0.5 divided by 2 times 0.1524 times 0.4 plus 0.5. That gives a numerator of 0.2 divided by a denominator of 0.274 for a final result of 0.73. And 0.73 is greater than 0.66, so this aperture passes the area ratio rule. Here's the last objective for this section. If you can get this one, then you've got it down. Given these aperture dimensions, T equal to 5 mil, L equal to 0.3 millimeter, and W equal to 0.27 millimeters, and pad dimensions of the same L and W. Apply the area ratio rule and recommend a change if needed. Now, it's on to the next section. We're back together again in section 4 about the 5-ball rule. Now we're going to talk about solder paste and paste type. Solder paste is made up of metal balls and a variety of liquids and suspended solids that we'll collectively call flux. Solder paste is characterized by the size distribution of the metal balls. This is called solder paste type. Let's talk more about the size distribution of the solder types. Solder paste types are specified by numbers. Here we have solder paste types 3, 4, and 5. And each of them has a size range of the metal balls in the solder, shown here in units of microns. For instance, type 3 has a size range of 24 to 45 microns, so that the largest size in the range is 45. For type 4 solder paste, the largest size is 38 microns. And for type 5 paste, the largest size is 25 microns. Now we're prepared to state the 5-ball rule. At least 5 balls of solder must fit into the narrowest stencil aperture dimension. Since, for us, the narrowest aperture dimension is always width, we have the following. W must always be greater than or equal to 5 times the largest ball size. For type 4 solder paste, the largest ball size is 38 microns. Time to meet the first objective of this section. State the 5-ball rule, either in words or using an equation. Here's an example of how to use the 5-ball rule. What is the smallest aperture that can be used with type 4 solder paste whose largest ball size is 38 microns? The 5-ball rule says that W should be greater than or equal to 5 times 38 microns, which is equal to 190 microns, so that the smallest allowable aperture width is 190 microns. Here's the last objective of this section. Calculate the minimum aperture width for type 5 solder paste, which has a largest particle size of 25 microns. That concludes this section on the 5-ball rule. Now it's off to the summary section and one last objective. Welcome to the summary section. We're going to review aperture dimensions and 3 rules that can help ensure a better print. The 3 aperture dimensions that we specified are the length, L, the width, W, and the thickness, T. Using those dimensions, we determined and applied 3 aperture rules. The aspect ratio rule, where W over T must be greater than 1.5. The area ratio rule, that states W times L divided by 2T times the quantity W plus L must be greater than 0.66. And the 5-ball rule, that says the aperture width must be greater than or equal to 5 times the largest ball size. Well, you've made it. This is the last objective of this module. State the names of the 3 aperture rules. Okay, that completes this module on 3 aperture rules. Want to be the first in line for the next educational module on manufacturing electronics? Hit that subscribe button. You'll be happy you did.